Alrighty, and here are the notes, the last notes from this section on page 31. So again, we've got a piecewise function here, and they want us to use the three-part definition of continuity to create a system of equations and then find the values of a and b so that it's continuous. This is continuous for all real numbers. Okay, so I want to think about what's going on here. I know that, again, these are all polynomials, so I know that I don't have to worry about there being any discontinuities anywhere except for right here. So if this was continuous, then they would all equal, or this would equal 6, and this would equal 6, because x of -1 is 6. So what I do is I'm going to say, all right, 2ax minus b has to equal 6, and ax squared plus b has to equal 6. Okay, and it has to equal 6 at the point x equals -1. Okay, so let's see. At x equals -1, then this would be -2a minus b. And this would be a plus b. So all I have now is a system of equations in two variables. And I'm just going to add these up. So I'm going to come over here. I'm going to put this one on the top just because I feel like it. Okay, so this becomes -a. That cancels out. Is 12. A is -12. Okay, if A is -12, and I plug that in right there, then I would get, let's see, -12 plus B equals -6, or excuse me, 6. So B is 18. Okay, so I found them. I got to use that definition there. So I'm going to say, all right, the limit as x approaches -1 from the left of f of x is equal to 6. The limit as x approaches -1 from the right of f of x is equal to 6. And f of -1 equals 6. So therefore, we know that this is continuous. Okay, so let's look at putting it all together. All right, so say we have a piecewise function right here. And we want to find the limit as x approaches 3 from the left. All right, I got to use this direct substitution. That is 7. As we approach 3 from the right, that is 3 squared. That's 9. G of 3, well, G of 3 would be right here. So G of 3 would be 9. Okay, how about the limit as x approaches 3 of G of x? Not the same. So this does not exist. Okay, is the function continuous at 3? Nope. So I'm going to say G of x is not continuous. And the reason, I'm going to say because the limit as x approaches 3 from the left does not equal the limit as x approaches 3 from the right. And the limit as x approaches 3 of G of x does not equal. Okay, so that is the big picture. Find the limit from the left, limit from the right, make sure that those are the same, and they are the same as the function at that point, and you are guaranteed that the function would be continuous there. That's it.